Hey guys, thank you so much for joining another session of Python fundamentals. So as we discussed, we will be doing 9 levels. So this is the meetup where we'll be posting the sessions, .NET Learners House, and the session is level 1, session 3. So let's quickly look into that. What is that we are going to do now? As we discussed already, that's a 9 level. That's a level 1, knob to nerd. And we completed 2, and there's a third session. And the resources for this is here. This is my GitHub repo where you will have all the coding or the items which I'm doing will be here. And very specifically, the Python fundamentals, all the level 1 and level 2, and everything will be here. So the recording of that is here. When you click on this, it will take you to this. It will take you to this one, where you can see this session 1 and session 2. Session 3 is now. It is live, so you'll be able to see all these things. So that's it. So let's get started. What is that we are going to do? So this plan also we have seen quite a few times. We have seen that plan. And now let's see what is that we do have for today's session. So before that, I just wanted to give you a little bit of tip on that. So I'll keep this here. We'll come back to this one. Let's get started with today's session. I'll just close this and let me come back to the. I hope this is little this is visible. I think the screen is, the font and the contrast is visible, and I'll increase this one also a little. So we'll be spending time on arithmetic operators, comparison operators, assignment operators, understanding the operator precedence, using of parentheses, and build a simple calculator. So that's the one. So prior sessions, as I was mentioning, it is already given in the playlist over here. If you go to that Python fundamentals repo, you will find this, and the master plan is here. If you click on this, it will navigate to the master plan where you will be able to see that 9 levels. Right now we are here, Python basics, then control for functions, data structures, operating, object-oriented programming, modules, packages, a lot of things are there. So let's worry only about the current path or the current module where we are. Okay, everything is in the GitHub. So let's get started with this. Hope if you missed, please go ahead and watch the playlist. The previous 2 sessions are here. You'll go and watch it, and this is the third session. So now we'll see this arithmetic operators. Anyone without programming knowledge also, they definitely know addition, subtraction, multiplication, and division for sure. Modulus is something which you want to calculate a remainder of 2 numbers. You use that. And something new is floor division. I'm calling it as an integer division, but we will see that what it is. You can see, and this is power of 2 to the power of 3. Okay, exponentiation. So that's the one. So we'll see this. I'm coming using this pi because this gives colors if you want to print something. So that's the reason I'm sticking to this, or else we can stick to this. When I say Python, everything will be in blue and white instead of black and white. Okay, let's see what is this arithmetic operators. So let me place this. You can see that 10 plus 5 and 10 minus 5, and the multiplication operator will see this. Okay, And here you will see something new. We'll see this. Here you can see, even though we don't have anything outside the decimal point, but still when you do a division, it will definitely give you dot zero. Okay, here if the remainder or the after decimal is 0.75, so even if it is nothing after that, it's zero, but still it gives you a float value. That's very important to understand. Now if you don't want that, you can do this. Again, we'll revisit this in a minute. Now if you see that here 15 divided by 4 is 3.75, this one. 15 divided by 4, that is floor division, like integer division. That means it will give only the integer side of the word. Now let's revisit this piece where we said that 10 divided by 2, it is giving 5.2. Now if I come back here and if I don't want even the 0, even for that I can use the floor division. Okay, it's not still float because we just copied it. It's not float anymore. It will be purely this. Okay, that's one tip I wanted to give, that here where we are using it, so that correlates to the previous sample. I just want to put it there. Now let's come back to this. Similarly, we are seeing other couple of examples is this, where we get 3.4 and 3. And here in the negative side of the word, it moves further. That means we expect if you see that 15 divided by 4 here, let's see this piece here. If this piece is this, it says 3. And when you have the negative, it goes to -4. It's on this other side. And the modulus operator is when you want to know the remainder of the operation. So if you see that 15 modulus 4 remainder is 3, 10 modulus 3 remainder is 1, 20 modulus 5 remainder is 0. Okay, so that's one thing. So where do the common use cases, where do we use it? So there are a couple of use cases. One is when you want to check whether, simple one, whether a number is prime or not, odd or even, odd or even number. So that's one of the use case. Multiple use cases that I listed a couple here. And you can see that when you want to check that, okay, 15 divided by 15 modulus 5, is the remainder 0? Yes or no? It's true. If 15 modulus 4, is the remainder 0? No, it's not. So even in that case, but it gives, if you see this, if you execute this expression, that if you purely execute this expression, it gives 3. So 3 equal to 0, it is false. So that's a comparison operator. Now, exponential thing, which we will see that, let's see these 3 expressions first. So you can see this 2 to the power of 3, 5 to the power of 2, 10 to the power of 0. Anything to the power of 0 is 1. So it is 0. Sorry, it is 1. And if you want a square root, we can use this to the power of 50% to the power of 33.33333. So here you can see that square root, we say that it's 16 to the power of 0.5 and 27 to the power of 1 by 3. So that's a cube root and square root, couple of simple one. So we have covered the arithmetic operators. We performed the basic math operators, then explain the difference between the single slash and double slash, that's a floor division, and use the modulus symbol to find the remainders, and use double asterisk to find the power of. Now we'll do the comparison operators, where we see that when we do here, if you see number, number equal to 7. Here we are using single equal to. Single equal to is called assignment operator. We'll come back to that, but I just wanted to compare when we're doing this. The single equal to is assignment operator, and when we use the double equal to is a comparison operator. Now if you see that the comparison operator will check the equality, it's a case sensitive one. I will execute this. Now you can see that is 5 equal to 5 true, 5 equal to 3 it's false, and hello equal to hello, that's true. Here hello H capital versus low capital, lowercase h, uppercase h, it's false. So that's one thing. Not equal to, you use the exclamation and the equal symbol. So that's one thing to follow when you're doing this. Let's see that. So is 5 not equal to 3? That's true. 5 not equal to 5? That's false. Okay, so that's cool. So let's check the greater than and the less than symbol. Let's see that. Here we saw 10 greater than 5 true, 10 less than 5 false. So that's one thing. Now let's go and check the greater than and less than symbol again. Oh, this is greater than and equal to, less than and equal to. Is 5 greater than or equal to 5? That's true. 5 less than or equal to 10? That's also true. So common mistakes, as I was mentioning, you should be a little bit careful because this is a fundamental series. I am stressing a little bit on this one. When someone is learning this fundamentals of programming, you need to be a little bit careful towards these equal to symbols. A single equal to is an assignment, double equal to is a comparison operator. Now see this here, x equal to 5, this is an assignment. X equal to 5, this is a comparison. X equal to 10, this is a comparison. So the first statement is assignment. The next two statements are the comparison operators. So the first one is the assignment operator. Okay, so let's see, write that piece over here. So that's an assignment operator. It's an assignment, and rest of the two things are the comparison. And here the different data types we are comparing, int versus float. It's perfectly valid. There are some things which we have flexibility in Python, we don't have in other compiled languages. So we're comparing int and float and different comparison operators between int and float. Here we are doing the comparison operators with strings, and it's purely based on the alphabetical. Like if you see that apple versus banana, the first characters between two strings itself is apple and banana. Okay, a is less than b, that's true. Here a b c, a b d, a and b, a and b. The last character is c versus d, which is lower, it is this one. So that's the one. So you can chain an operator, like we have an x equal to 5. So that means you're saying that 0 is less than 5. That's true. And that is less than 10. Totally true. Age is 25. We're saying 18 is less than or equal to 25. True. And 25 less than or equal to 85. So this is also true. So let's execute this block to see how it works. So both are returning true. One thing I would like to highlight over here is sometimes the REPL works a little bit different from the .python files. So you need to be a little bit careful. If at all you are getting something undesirable output, it does not mean that you are wrong. Might be that REPL works differently versus the .py files where it works. So let's see the assignment operator. Here you can see that equal to, plus equal to, minus equal to, multiplication equal to, division equal to, floor division and assigned, modulus and assigned, power and assigned. Like you have 5. I'm saying that number number equal to number plus 1. So instead of that, I can say that number plus equal to 1. So it's a simpler way. It might lead to errors if you don't understand or write it properly. A little bit experienced programmers, they understand. Like you can see that x equal to x plus y. You can write it x plus equal to 5. The same expression, you can write it in a shorter way. But you need to understand there are chances that we might do mistakes, but if you are well versed with that, there is no issue at all. You have to be a little bit careful. That's the only thing. So let's see this expressions over here. So we're starting with the score. It is 100. And now we are saying we are adding 10 to that. So instead of saying that score equal to score plus 10, I'm saying that score plus equal to 10. So that means it is equivalent to score plus 10. Now here we are subtracting the score by 25. So we are saying that score minus equal to 25. It's as good as score equal to score minus 25. It's the same expression. Now double the score, it's to the power of or multiply. It's not power, I'm sorry, it's multiply. It's a single asterisk. So score into 2, score equal to score into 2, or score into equal to, multiply equal to 2. That means 85 into 2, 170. So that's what being assigned. Now if you want to do a half, so we're saying that score equal to score divided by 2. So which is assigning to 85. We are back to the square one. So why use this? The same expression you are writing in two different ways. So this is a little bit verbose. I don't want to tell that it is cleaner, but if you are experienced programmer, you want to avoid this repetition, we can go ahead with this, but it's again a personal choice. Which one works better for you and your team, you guys can follow that. So that's the same expression, whatever we are doing there, again we are doing it in a shorter way, like counter plus equal to 1. It's same as counter equal to counter plus 1 or counter plus equal to 1. Both are same. And the string concatenation also it works. We see that we are seeing the saying message equal to hello, then plus equal to empty string, then message plus equal to world, and exclamation entirely hello space world exclamation. Everything we are combining. So that's a second one. Here I would like to give one tip which I forgot to give it in a previous one. So we have to come out of this. I'll wait till we complete this theoretical part, and then we will learn that one. So we learned about plus equal to, minus equal to, divide equal to, and also the plus equal to for the string concatenation. All is well. Now operator precedence, we always know that parenthesis, exponentiation, multiplication, division, floor division, modulus, plus minus, and this way comparison operator equal to this way operator precedence are. So why do we need the operator precedences? Two reasons. One reason is the way you want to calculate, and other one is the readability. Now if you see this in this expression, based on that operator precedence, we don't have parentheses, we don't have exponentiation, we have multiplication. So the first, this expression will be calculated like 3 4s are 12, then plus 12 plus 2 is 14. But if you do this, it is as good as this. But if our intention is first I want to calculate 2 plus 3 5 into 4 20, just to avoid the confusion, it is better to have the parenthesis in between, so that way it will be easy to calculate. Like if our expectation is something else. Better to be explicitly specify that. Now here, the all the three expressions we are calculating here. So how it gets calculates is this one minus this. So first it is doing the 6 by 2 is 3, 10 minus 3, up based on the operator precedence. And again it is 3 to the power of 2 into 2. Okay. So using parentheses is much cleaner. Like you can see the difference without parentheses and with parentheses. Here you can see this without parentheses, it is calculating to 14, and with parentheses it is 20. So always it is better to have parentheses from the clarity perspective and from the desired output perspective. It's better to have that. So that's what we were having. I mean, even such big an expression, it is very easy to understand when you see that. See here, based on the operator precedence, it calculates. Like you can see this 4 3s are 12, and then this expression, and then it does plus and then minus. So it's the same thing. It's calculating this and it's calculating this, and then addition of this and whatever is the value, it's getting deducted from this. So that's the better way. I mean, here we are not, until unless you remember the operator precedence, we don't know that how to read this expression. Now here it is at least a little bit clarity. Oh, okay. First is this, and then this, or this and this, whatever it is. First we have two values, and then remaining it is easy. Like this value 1, value 2, value 3, this plus and minus symbol. So plus comes first. This expression is evaluated, and then the value of this expression will then evaluated with these two. So common formulas, you know that simple average. Let's look at this. Okay, and another one is pi, where we are having the pi and radius to the power of 2, and temperatures Fahrenheit and Celsius formula, typical one which we use while learning. So operator precedence, which we have seen. Now let's come to the hands-on practice. Now when we come to the hands-on practice, I just wanted to take the piece which I wanted to talk. Now if you see that there are no other files or folders within this. Now one thing we discussed about the bytecode in the first session, we saw that here the Python files will be converted into bytecode, and that bytecode will be executed by Python virtual machine, and that's how it is a compiled and interpreted language. Now we explicitly used disassembler module this.des to find out. The other way to do is, that's what we are going to see now. So if I want to compile any single file, I mean that creates a bytecode, whatever we execute now. So right now under S3, we don't see anything. If I come in here, I'll say that, okay, now compile only the first file. Now after that, when you come, there is known as a PyCache, in which whatever the individual file which you have given, so that will be converted, and this is a bytecode. So we'll again revisit about the bytecode a little later. So let me come back and delete this PyCache, or just I'll keep it and delete the bytecode which we generated. Another way to do is I'll come here and I'll say that compile all dot. So within the folder, all the Python files, whatever are there, go and compile it. Individual files, if you want to compile, you can use this one, py-compile, all the files within a folder you want to do that, you can compile like that. Now, if you come back to this folder, you can see all three source files has been compiled and has got its bytecode inside this. So let's keep it here. So this is a tip I wanted to give. So let's carry on. We completed all. Let's see the today's programs. So I'll close this and I'll close the docs and come back and see the arithmetic operators. So here you can see that arithmetic operators, we are using F strings. That's good. And we're using addition, subtraction, multiplication, division, floor division, modulus, and exponentiation of the power of e to the power of 2, and the value of a is 15. And again, if it is modified somewhere, it will be something different. And here also you can see number 17, and reminder is uh, number. That means technically 17 reminder modulus 2. It gives the reminder. If reminder is 0, the same thing what we saw. We saw the square root while learning. And here we are seeing the operator precedence. So let's come back here. Let me do a clear screen pi. I'm going to execute that. So we see the all the operators are being used, and a simple odd or even number is being calculated, and how the operator precedence or using of parentheses will help us have the clarity and desired output. That's one thing. And second thing is, let's see today's second program, where we are using the comparison operators. We are seeing that equal to, not equal to, less than, greater than or equal to, less than or equal to. And here we are seeing the chaining of comparison operators. Sorry, chaining of operators. And here again, chaining. And here we are accepting an int value, and then we are testing whether whatever the score which we give as part of the input, whether it is falling under 60 or greater than 90 or greater than 60, or it's in the B range. So let's execute this and see pi 02. So mine is 60% range. I'm not studious guy, so it's is passing is true, but I'm not excellent. I'm not in a B range. I'm an average guy. So let me use the mini calculator, the third sample. So where we're accepting two values. As we saw, the input string will return the string, and that we are converting into float. So num1 and num2 both are float values. And here we are calculating some subtraction and multiplication, and then we are seeing that handle whether it's divided by 0 and power of a small calculator kind of thing, pi 03. So I'm saying 12, and the other one is 24. So 36 minus 12, and the multiplication and the division, floor division, modulus, and power. And this one I just wanted to show you while we are here. Yep, this one. Now you can see this value we have given is giving in a scientific value. Now if I remove that and remove this, now it's giving in a complete integer value, because these are float. It's giving in a scientific value. Okay, so that's it for this session. Let's see what is stored for us in the session 4. Let's go back to the documentation sessions and what is planned. Let's get into the preview, and you can see that we have completed. It's this format: phase A, phase B. Phase A, we will have 4 sessions, followed by quickly a mini project. Then phase B, 4 sessions, followed by another mini project. Okay, so that's we are calling it a level 1. So similarly, we'll have 9 levels. So we have completed the third session. So the next session will be fourth, conditional indentation introduction to modules, before we jumping in to the mini project. Some of the things which we introduce directly without even discussing what it is, and then we will revisit. Like directly we are writing functions here in this simple calculator. So we'll learn, and again we'll revisit. As I was mentioning, we'll learn. Sometimes we'll introduce something and then we'll revisit again and again, or sometimes we'll all of a sudden we'll come and we'll discuss about something, but again definitely we will revisit, we'll learn that. Okay, thank you so much, thanks for joining, and let's catch up in the next episode. Thank you.